Welcome back, Unit 2, Lesson 5. We are still working on conditional probabilities. We left off with example 4, and let's get going. It's been a rocky start to the morning. Our school has a half day today, and before homeroom or crew even started, there's a fire alarm, and it was not planned, and it's raining out. And I wore my nice new gray Pumas. I was really disappointed. But anyways, let's take a look at example 4. Okay, students at Rufus King High School were discussing some of the challenges of finding space for athletic teams to practice after school. Part of the problem, according to Kristen, because Kristen apparently knows everything, is that female students are more likely to be involved in after-school athletic programs than male students. However, the athletic director assigns the available facilities as if male students are more likely to be involved. That jerk. But before suggesting changes to the assignments, the students decided to investigate. Good call on Kristen and the students' parts, because anytime you go to make an argument, you want to have some information, some data to support it. All right? So, suppose the following information is known about Rufus King High School. And I'll highlight this. I was going to underline it, but you know my addiction to highlighters, okay? 40% of the students are involved in one or more of the after-school athletic programs, all right? It is also known that 58% of the school's students are female, all right? Also, 23.2% of the students are female and participate in after-school athletic programs. The students decided to construct a hypothetical 1,000 two-way table to organize the data. Now, this is an introduction to and I'm going to say it again, to a hypothetical 1,000 two-way table, okay? And all that is we don't have an exact number of students. We just have percentages. So we are going to just kind of say, hypothetically speaking, that's why it's called hypothetical, let's make it out of 1,000. If there were 1,000, then 10% of 1,000 would be 100. 20% of 1,000 would give us 200. It gives us numbers to percentages, okay? There might not actually be 1,000 students. Maybe there is, maybe there isn't. Maybe it's close to that, but let's hypothetically say there's 1,000. That's why this overall total number in my bottom right-hand corner is going to be 1,000, because this is a hypothetical 1,000 two-way table. Why do they call it two-way? We have two columns. We have two rows, all right? So I think the explanation is pretty self-explanatory. This is hypothetical, and 1, 2 columns, 1, 2 rows. A hypothetical 1,000 two-way table. All right, so let's start filling in said table here. All right, let's take a look at what we got. And I highlighted the important parts here. And before we move forward, let me just say this. That was a lot to read to do one problem. It's basically 2 paragraphs. Welcome to Common Core in the future. They give you a scenario. You have to read a lot. But what is really the only significant, important stuff that I needed to pull out? Everything I highlighted, okay? Just get through it, read it, pick out what's important, do the problem, and then move on, okay? And that's what we're going to do right here. So, highlighted in blue, so I'm going to use a blue marker. This blue, blah, 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 blah. Let me erase everything else. Highlighted in blue, it says that 40% of the students are involved in one or more of the after-school sports. So you see this column right here, participates in after-school programs, 40% of them. So the total is 0.40. That's my rate. That's my probability. It's 40%. However, what's the quantity that would go there? Well, out of my 1,000 students, I have 40% of them. So I just multiply them. I get 400. All right, 400. So this quantity, even though it's 40% or its probability is 0.40, out of my 1,000, that 40% represents 400 of them. And we're going to take the rest of what we have, the other 2 percentages, and fill them out. And that's going to allow us to fill out the whole entire table. So let's take a look at what we have here in yellow. In yellow, here we go. 58% of the school students are females. So where's my female column? Oh, you know what? So I'm so terrible. Highlighter. This I should highlight in blue because that's blue here. So our females, where are you at, ladies? Right here. Here's our female column. So my total is right here. And of course, this is yes, they participate in school programs, and here's that total right here. All right, so 58% of the school students are females. So out of my 1,000 students, 58% are females. So if I multiply those, I get 580. And of course, I can't write yellow on yellow, so I'll just call this 580. That's 0.58. That's how I got my 580 females. And last, but certainly not least in any way, shape, or form, 23.2% of students are both female and participate in after-school programs, okay? And this is great. This has just happened to be lucky, the way I picked these highlighters. If these are after-school sports, I participate in them right here, this column. My total is 400. And my females is this row, and the total is 580. Where is both? Right where they intersect. And look at yellow and blue make green. Mind blown. Sometimes it just works out that way. All right. If 23.2% are both, that means out of my 1,000, I multiply it by 0.232. And the actual quantity, or 23.2% of my 1,000, is 232. So 232. Look at us go. Wow, that worked out great. So I said, after we put in those numbers, we should be able to fill out the rest of the table. And we can, right? How so? Well, look at my participates in sports. Look at this column right here. This is the total. If I add the females and the males that participate in sports, I should get 400, which means I need to add 232 to some number to get 400. And that number, 861. 168 males participate in one or more after-school sports, okay? Now look at, if I add 232 and 168, I get my total, 400. So that's how we're going to be able to fill in the rest of these. We're going to be able to figure out what number we need for the totals. So let's look at our female row, the one that's highlighted yellow. There are a total of 580 females. 232 participate in sports. That means I should have a number that does not participate in sports, that if I add it to 232, gives me 580. All right, and that's going to give me, wait for it, 348. Yeah. I think that's right. That is right. Okay. Now, let's look at this total column right here. If I add up all my females to all my males, I should get 1,000 students. So 580 plus what is 1,000? 420. Okay, well, let's do something else. Let's look at our male row. This row right here, moving left to right. 168 plus something is going to give me 420. Oh, you had to do it, didn't you? 200. No. Yes. So I had 300 is too much. Oh, I'm going to make that a 2 to make the last number 0. I'm going to carry the 1. 20, that'd be 5, carry the 1. 252. I think that's right, but you know what the good thing is? And I'm going to do this. I believe I'm right. But if you're just unsure, if you just want to check your work, I don't need to rely on the calculator to do the work. I'm going to use the calculator to check the work. How come? Well, because we're doing all this work. It would suck to be wrong because I missed one number. Okay? Because eventually we're going to make probabilities off of these numbers. Okay, so if I have 168 and I add it to 252, does that give me 420? It does. We're good to go. All right, use the calculator to check. And last but not least, it's the easiest one, the totals on the bottom row. 400 plus something is going to give me 1,000. That something is 600. That means these two should add to 600 if I go down in the column of people that do not participate in sports. And they do. I'm right. Now, it's a lot of highlighting and poop. So let's do this. Let's fill this table in without the highlights and all this jazz. 580 and 420, right? Oh my goodness gracious. So I've got 580 and 420. Okay. 348, 252. 348, 252, and this is our 600. Right? 232, 168. 232, 168. And of course, this bottom mess here is 400. That might look a little bit easier to read. And now it's all purdy. We'll erase all this jazz here. Erase all this jazz here. And now we got a nice clean table. And from our nice clean table, 3, we are going to now figure out some probabilities here. Okay? So the following letters stand for the following events. Okay? M is male. Okay? M is male. Okay? F is female. All right. And then we got Y is yes, I participate in after-school sports. And let's go with a lighter orange. Red, can we do a pink? How about that? Oh, pretty. Does not participate. I should have made that the women. Okay. Does not participate in sports. So those colors sort of coordinate the columns here. And let's get rid of this. Now it's pristine, with the exception of, yeah, OCD kids. There we go. Clean. Love it. Now, find the probability that we have chosen one student at random and that they are F, which is a female. Okay? So how many females do I have out of my student pool? Well, I have a total of 1,000 students, and 580 are females. So that's 580 out of 1,000. And that's it, I'm done. Okay? If I were to make a decimal out of that, I believe it would be 0.58, which would make sense because look up here, 58% of the school students are female. All right? That works. So let's move on to the next one, B. It's in purple. Yes, the probability that, yes, they do participate in sports. Doesn't matter if they're male or female. I just want everyone that participates in sports. That's this column right here. The total is 400. So 400 out of my 1,000 participate in sports. All right, that's cool. I like that. That's good. Is that something else we got here? No, that wasn't given. Oh, look at 40% of the students are involved in one or more after-school sports. I mean, that was given to us. If I divided 400 by 1,000, I would get 0.40. It's good. Now, participates in after-school sports and is a male. I need both of those. So what I'm going to do is get my highlighter again. And I'm going to say, okay, here's the male column. Here are the people that participate in sports. I want both. Where do they intersect? 168 are both male and participate in sports out of my 1,000 total. All right? So I'm going to say it's 168 out of 1,000. And in fact, let's get rid of that highlighter. So 168 out of 1,000. Okay? And the fourth one, D. All right, given. We have given again. Okay? The probability of someone not participating in sports, given they're male. All right? So out of all the males I could choose from, which of the males do not participate in sports? Using a table to me is a lot easier. So I am given my males. I can only choose out of the 420. Okay? That's what I'm given. How many do not participate in sports? Again, I am looking only at the male column because that's what I am given. All right? So 252 do not participate in sports out of all the males that I'm given to pick from. So that is my probability. Now, we discussed another way. If we have n given m, I could say P of n and m over the probability of just m. Okay? This was the other way we could do it if we didn't have a table. Okay? If we had just percentages. So even if we did it this way, what's the probability? What are all the males? Well, 420 are males. That would still go down here. And what are both not participating in sport and males? Well, here are the not participating in sports. And you know the blue is males. So here's the intersection. It's 252. It still works. 252 out of my 420, which is what we got. So either way works. Just, reading on a table is a lot easier than actually calculating two separate things, in my opinion. But we don't always have a table. And sometimes we really need to refer to this thing right here. If you're a person who wants to refer to this all the time so you don't got to remember two ways, go ahead and do that. As long as you get the right answer and it's mathematically relevant, you're good to go. All right, example 5. Use the table below to find each probability. We have certain rows here. Students that earn less than a high school diploma, I guess a high school educational diploma. Some people that have some college, and others that have a college degree. And then this is their income. Okay, they make under $20,000, from $20,000 to $30,000, and over $30,000. All right, this is all nice and fine and dandy, but the one thing that's missing from this table are the totals. Okay, and any time that you take probabilities, you always need totals. Bar column on the right and bottom row. And ultimately, they should add up to the same thing. All right, so let's go ahead and put these numbers in. Okay, this total, whatever's in this bottom corner here, the far right totals and the bottom row totals should add up to the same thing. All right, but I already have these numbers for you. This is 107. Okay, less than high school. The high school row is 224. We have 438 that get some college and 436 that actually have college degrees. All right. We have 296 total that make under 20,000. 505 that make between 20 and 30,000. And 404 that make over 30,000. And if you add this totals column and add these numbers and this total row, you should get, both will add up to 1,205. So that's my overall total. There are 1,205 people, okay, that were in this survey, so to speak. So let's calculate some probability, shall we? Okay. The probability for A here, that an individual picked at random has less than a high school education. This is the row for less than high school education. There are a total of 107 of them out of my 1,205. So it's just that simple. 107 out of 1,205. Good, easy. That's the wrong question right there. Next, B. They earn over 30,000 and they have less than a high school education. This is where they need to do both. Both criteria need to happen. So, over 30,000 is this column right here. Boom. Less than a high school education is this row right here. All right? So, which earns over and has less? Only 2 people did both. That is 2 out of my 1,205. Slim pickings. C. The bang earns over 30,000 given has only a high school education. So remember our rule with given. All right? If we have a probability of one thing given something else, we are given high school education, that is the only thing that I can pick from. So if I grab my highlighter here, where is has a high school education? This row right here. So my probability needs to be only out of that 224 because that's what they're giving me to pick from. All right? So what are the chances that they earn over $30,000 given that they only have a high school education? This column right here is the over 30,000. Okay? 14 out of that 224. And last, my God, and certainly not least, D. All right. Has a high school education or less given. Okay, so this isn't the probability here. This is one of the criteria. Has a high school education or less given earns over $30,000. Okay. Let's figure out where the earns 40,000 or earns over 30,000 is first. Let's get rid of this highlighter. And let's grab another one here. We are given that they earn over 30,000. That's this column right here. This is the one we're given to pick from. Okay? Now, we need to pick out of that 404 that we're given to choose from. Either has a high school education or less. Well, here's high school education. And less than a high school education. So really, they're asking us for 2 things, high school education or less given. So I have 14 that have a high school education, and I have 2 that are less than. So that satisfies both of those. All right? There's 16 out of my 404 that both make over $30,000 and have either a high school education or less. So that's 16 out of 404. We are done. See you later. Unit 5, Lesson 3. I'll see you then.